A Harvard astrophysicist believes there's a strong likelihood this is a craft of alien origin.
The moment has arrived. 3I Atlas, the interstellar visitor ripping through our solar system, is finally revealing itself in full. And what astronomers are seeing is decidedly more extreme than expected. NASA has announced the release of a fresh set of images gathered from multiple space and ground-based observatories that show the comet's activity and structure in startling detail. While these images were eagerly awaited, they've also brought with them a growing sense of unease. The data indicate that 3I Atlas is exhibiting behaviors and features more chaotic, more volatile, and more dramatic than standard cometary models would predict. Before we start, smash the like and subscribe buttons for more updates. From the first glimpses, it was clear that this object is no run-of-the-mill comet. Discovered on July 1, 2025 by the Asteroid Terrestrial Impact Last Alert System Atlas Telescope Network, 3I Atlas quickly revealed its interstellar pedigree. It is only the third confirmed visitor to our solar system from outside, following 1I Oumuamua and 2I Borisov. The new images now show a nucleus wrapped in a teardrop-shaped cocoon of dust, multiple jets streaming off, and tails that curve and fan in unexpected directions. These features are compelling, in part because they seem to challenge what astronomers assume about how such interstellar objects should behave once they enter our sun's domain. One of the standout revelations is the morphology of the dust envelope itself. In earlier images, the comet displayed a more modest appearance. Now the high-resolution shots indicate a distinct teardrop silhouette enveloping the icy nucleus, a shape hinting at strong directional outgassing, considerable motion of ejecta, and perhaps multiple bursts of activity rather than a steady, gentle sublimation. The Hubble image from July 21, 2025 captured the growing dust cloud clearly and showed that even at a distance of around 270 million miles from Earth, the object had already begun serious mass loss. What makes this significant is that such a pronounced dust cocoon implies a higher energy process than a typical comet passing through the inner solar system at this heliocentric distance. Adding to the intrigue are the multiple tails visible in the new imagery. One of the recent reports highlights a multi-tailed alien comet photobombing a galaxy. The language may be sensational, but the science is solid. In one shot, the comet is seen against a distant galaxy backdrop with at least two prominent tail structures, a typical dust tail and an ion tail, each with distinct directional signatures. More so, jets have been detected both toward and away from the sun, suggesting complexity in the outgassing process that may not align with standard solar-driven comet behavior. The fact that the sunward side is active, ejecting material in the direction of the star, raises questions about the interplay between internal volatiles, solar heating, and possibly structural heterogeneities within the nucleus. It's when you dig into the compositional data that the picture becomes even more disconcerting. Observations by the James Webb Space Telescope and other instruments reveal that 3I Atlas harbors a gas coma dominated by carbon dioxide, with a CO2 to H2O ratio much higher than what is typical for comets originating in our solar system. This suggests that the nucleus may have preserved ices from a very different environment, perhaps one that formed under conditions unlike those in our protoplanetary disk. Coupled with detection of water ice absorption, large icy grains in the coma, and activity at large heliocentric distances, when sublimation should be weak, the image emerges of an object that may have been shaped by dramatically different evolutionary forces than those we typically study. Why does this matter? Because the stronger than expected outgassing, multiple tail structures, and unusual composition all point to a possibility. 3I Atlas could be far more active and volatile than many previously encountered comets. When it approaches perihelion and deeper solar heating kicks in, the risk is that it may disintegrate, fragment, or erupt in unpredictable ways. That it is already showing such signs at a distance and stage when we thought activity would be moderate suggests it might become more dramatic, even chaotic, as it nears the sun. The worse in the title isn't meant as a threat to Earth. The object will pass well outside any danger zone. Rather, it's worse in the sense of more troubling to standard comet models and more extreme than we bargained for. A further twist comes from the timing of the image release. NASA's schedule places a big reveal at 3 p.m. EST 20 UTC on November 19, 2025, with multiple observatories contributing to the dataset. With that window comes a sense of anticipation, but also impatience within the scientific community. There have been questions raised about the delay in releasing some Mars orbiter images of 3I Atlas when it passed near Mars earlier in October. That delay raises the specter of hidden or unexplained complexities contained in the data, fueling speculation that the object may not be behaving in a conventional way. For the purposes of this discussion, the focus is on the event, the images themselves, and the implications they carry. The implication for comet science is profound. Historically, comets from the solar system have served as time capsules of early solar system conditions. They form, evolve, sublimate, and degrade within predictable regimes of heliocentric heating, volatile loss, and tail formation. An interstellar object like 3I Atlas offers a rare chance to compare foreign Finnish comets against our homegrown population. If it diverges significantly from those norms, then our models of comet behavior, dust production rates, tail dynamics, volatile sourcing, nucleus integrity, may need recalibration. We may find that interstellar visitors carry compositional and structural inheritances absent from our solar system, and that they respond differently under solar heating. In this case, the more extreme behavior of 3I Atlas could force us to consider a new subclass of active objects. There is also a philosophical and methodological implication. If 3I Atlas is operating differently, that suggests our observational regime, which has been honed on solar system comets, might not be entirely adequate for objects from beyond. Observatories may need to adjust how they monitor outgassing, fragmentation risk, jet dynamics, and nucleus behavior. The new images reveal that jets may not always emanate away from the sun as textbook states. Dust cocoons may form unusually, and that composition may drive very different activity patterns. It forces researchers to ask, are we seeing the tail end of a process constrained by a different progenitor environment? Are the structural properties of the nucleus, layering, volatile inventory, porosity, simply different enough to upset our assumptions? If so, 3I Atlas is showing us what we didn't know we didn't know. Another key implication concerns the potential danger of surprises. The solar system's comets are broadly predictable enough such that we have developed mitigation strategies for potential impacts, and we know how to estimate outgassing forces for trajectory predictions. When an interstellar object enters and it behaves more erratically than expected, it could slip our predictive models. 3I Atlas's strong jets, multiple tails, and unusual composition raise the possibility that similar objects, encountered perhaps one day on a collision course, could defy standard modeling. The event reminds us that the unknowns in planetary defense may include visitors from other star systems, and the images now shown by NASA hint that they may be less benign and more complex than we assumed. Operationally, this data release also underscores how coordinated modern astronomy has become. NASA's media advisory states that multiple spacecraft and telescopes have contributed imagery to the release. It reflects a capacity to mobilize assets rapidly for transient events, enabling high temporal and high-resolution coverage of a brief cosmic window. That said, the very fact we are now seeing worse than expected behavior also means that scientists must be nimble in adjusting expectations and analysis workflows. They must sift through perhaps surprising jets, dust morphologies, and compositional signatures rather than fitting the data into existing frameworks. The new images are, in effect, a kind of wake-up call. The cosmos still holds freak visitors, and we are seeing one now. From a pedagogical perspective, these images will serve as a teaching tool, not just for comet science, but for interstellar object research writ large. Students and early career researchers will likely turn to the NASA dataset to study how a hyperbolic comet behaves in unknown territory. What happens when material formed around a distant star system enters a deep solar heating environment? How dust and gas release may differ, how tail structures evolve in unusual geometries. The worseness in the event means the dataset is richer in surprises and therefore richer in educational value. We will see papers, modeling efforts, and perhaps even revisions of comet dynamics textbooks predicated on this event. There is the public engagement angle. Moments like these capture the imagination. An alien object roaring through our system, behaving oddly, revealing secrets about another star system. NASA's announcement and image release will likely feed media narratives of strange comet from another world, but stripped of sensationalism, the deeper story is one of scientific humility. Nature handed us a guest we didn't fully anticipate, and we are scrambling to keep up. The images released today will set the tone for how 3I Atlas is perceived by both the public and by science, as a fascinating disruptor rather than a passive visitor. In short, the event of NASA sharing these new images of 3I Atlas marks a turning point. A comet from another star system has not only arrived but is behaving in ways that demand attention. The teardrop-shaped dust envelope, multi-jet outflows, multiple tail geometries, and anomalous composition all point to an object that is getting worse, in the sense that it is much more active, much less predictable, and much more challenging than standard models allow. What happens next as 3I Atlas continues its journey will be closely watched. But for now, the images themselves have already changed the story. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA's new 3I Atlas images and what happens next now? We want to hear from you. Thank you for watching and see you next time.